The disc harrow is a cornerstone of conservation tillage, balancing efficient soil preparation with environmental sustainability. Unlike intensive tillage systems that disrupt soil structure, this implement is designed to maintain soil health, preserve organic matter, and minimize erosion. Its key functions include residue management, efficiently cutting and incorporating crop residues into the topsoil while leaving a protective layer on the surface to reduce erosion. Shallow tillage, operating at reduced depths to avoid excessive soil disturbance, safeguarding the soil's natural layers and its beneficial microorganisms. Weed suppression, managing weeds by cutting and mixing them into the soil without unnecessary disruption. Soil moisture retention, retaining moisture by leaving residues on the surface, which reduces evaporation and supports water conservation. By integrating these practices, the disc harrow ensures a sustainable approach to modern agriculture. Key benefits include erosion control, retaining crop residue as a protective cover, significantly reducing wind and water erosion. Energy efficiency, operating with lower power requirements than deep tillage tools, conserving fuel and reducing operational costs. Improved soil structure, preserving organic matter and fostering soil biodiversity by minimizing soil disruption. Flexibility, supporting both residue incorporation and surface leveling, adapting seamlessly to conservation systems. Designed for conservation tillage, the disc harrow offers advanced features such as shallow disc gangs, optimized for minimal tillage depth to avoid soil inversion. Residue-friendly design, serrated discs that enhance cutting and incorporation of crop residues. Flexible gang angles, allowing precise adjustments to manage residue without overdisturbing the soil. Optional light rollers, gently firming the soil surface while maintaining protective residue cover. With these advantages and features, the disc harrow ensures effective soil management while promoting environmental sustainability. Main parts of a disc harrow. The frame is the main structure that supports all other components. Mounted on the frame is the gang, which consists of a set of concave discs attached to a common shaft, designed to cut and mix the soil. These discs are positioned on a gang axle, a shaft that ensures smooth rotation. The gang angling mechanism allows the angle of the gang to be adjusted, depending on soil conditions, for more efficient operation. To keep the discs clean and prevent clogging, the scraper removes soil buildup from the concave side of the discs. The hitch connects the harrow to the tractor, providing a stable attachment, while the transport wheels support the harrow during transport and ensure proper ground clearance. On the right side of the slide, you can see a disc harrow in action, with the working width, disc position, and overlap clearly illustrated. These visual elements help demonstrate how the harrow operates in the field, ensuring optimal soil preparation while maintaining efficiency. To ensure the best performance, here are the recommended working parameters. 1. Working speed. For light soil, the optimal speed is between 6 and 10 km per hour. In heavier soils, reduce the speed to 4 to 8 km per hour for better soil control. 2. Working depth. For primary tillage, a depth of 10 to 15 centimeters is ideal for breaking compacted layers. For secondary tillage, a depth of 5 to 10 centimeters is sufficient for seedbed preparation. 3. Disc diameter. Smaller discs, 450 to 500 millimeters, are used for light tillage and seedbed preparation, while larger discs, 550 to 650 millimeters, handle tougher soils and residue incorporation. 4. Gang angle, disc angling. Typically set between 15 degrees and 25 degrees, the gang angle controls the depth and aggressiveness of tillage, allowing for different soil conditions and tasks. 5. Overlap between gangs. A 5 to 10 centimeters overlap between the front and rear gangs ensures uniform coverage and prevents unworked strips in the field. 6. Power requirements. The power required depends on the harrow width and soil type, typically 15 to 25 horsepower per meter. For example, a 3-meter disc harrow would need a tractor with 45 to 75 horsepower. To achieve the ideal working depth with a disc harrow, several adjustments can be made based on soil conditions and the specific task at hand. Below are the key methods for adjusting the working depth, with examples shown on the slide for situations 3, 4, and 5. 1. Adjusting the tractor's hydraulic lift system. By raising or lowering the tractor's hydraulic lift, you can directly control the depth of the harrow, ensuring it operates at the desired level for the soil type and task. 2. Selecting the right disc diameter. The diameter of the discs affects the depth of tillage. Larger discs, 550 to 650 millimeters, tend to work deeper, while smaller discs, 450 to 500 millimeters, are used for shallower tillage. 3. Modifying the gang angle. Smaller angles, between 15 degrees and 20 degrees, reduce the tillage depth, making them ideal for light tillage. Larger angles, between 25 degrees and 30 degrees, increase the depth, making them more suitable for heavier, deeper tillage tasks. Visual example of gang angle adjustment on the slide. 4. Adjusting the transport wheels on trailed harrows. For trailed harrows, adjusting the position of the transport wheels can help change the overall depth of the harrow's working area. Visual example of transport wheel adjustment on the slide. 5. Adding spacers, segment plates. Spacers, also known as segment plates, can be added between the discs to modify the spacing and depth. This adjustment is typically used to alter the positioning of the gangs for different tillage needs. Visual example of spacer addition on the slide. Before starting work, it's essential to perform a thorough inspection of the disc harrow to ensure it operates efficiently and safely. The following images demonstrate key inspection points for checking the bolts and overall condition of the harrow. First image. Here, we see the entire disc harrow. Before use, it's crucial to check that all components are securely fastened and that there are no visible signs of damage or wear. A quick overall visual check ensures that the harrow is ready for operation. Second image. This image highlights the bolts on the disc holders. Each disc is mounted on a separate holder, with 6 bolts securing each disc. Inspect these bolts to ensure they are tight and undamaged. Loose or missing bolts can lead to disc instability, affecting the performance of the harrow and potentially causing damage. Third image. Here, we can see the bolts on the cleaner holder, the scraper. These bolts play an important role in keeping the scraper firmly in place, ensuring effective residue removal. It's essential to verify that the bolts are properly tightened to maintain consistent scraper functionality throughout the work. Regularly checking the bolts and components before use is crucial for preventing malfunctions and ensuring optimal performance during field operations. Before attaching the disc harrow to the tractor, it is important to ensure proper alignment and adjustment of the lower linkage arms to the width of the machine's attachment system. Step 1. Check the width of the lower linkage arms. The lower linkage arms must be adjusted to match the attachment width of the harrow. In this case, the attachment system is Category 2, requiring a width of 965 millimeters. This width can be adjusted using the side stabilizers, which are clearly marked in the image on the right. Step 2. Adjust the width to fit the attachment. After adjusting the linkage arms with the stabilizers, align them with the attachment points on the harrow. On the left side of the image, you can see the device used for attaching the disc harrow to the tractor's 3-point linkage system. This ensures the harrow is properly connected and ready for operation. Step 3. Attach the harrow to the tractor. Once the linkage arms are set to the correct width and aligned with the attachment system, securely attach the disc harrow to the tractor. Be sure to double-check all pins and locks to guarantee a safe and stable connection before beginning work in the field. This adjustment process is crucial for ensuring that the disc harrow is properly connected, enabling optimal performance and safety during field operations. Watch as the tractor slowly moves into position, aligning the ends of its lower linkage arms with the hitch pins on the disc harrow. The goal is to get close enough so the operator can safely step in and connect any lighting or hydraulic lines, if equipped. Before attaching these lines, inspect each connector for dirt or debris. If they're not clean, wipe them thoroughly to ensure a proper seal and reliable performance. This careful approach prevents damage to both the connectors and the harrow, while maintaining operator safety. Once all connections are secure and cleaned as needed, you are ready to move on to the final steps of attachment and operation. In this final step of attaching the disc harrow, the ends of the lower arms are equipped with automatic hooks. You need to open the mechanism at the ends and lift the arms, then lock the hooks to prevent the machine from accidentally detaching. Release the top link and position it at the upper point of the 3-point hitch system. It's recommended to place the ball first and then attach the top link in the same way as with the lower arms. However, as shown in the video, there is another method if you don't have automatic hooks. Be sure to insert the linchpin, which secures the ball onto the hitch pins on the disc harrow's hitch axle. Exercise caution to avoid injury, as the linchpin can cause pinching. Finally, lift the machine and do another visual check for any potential damage or irregularities, as well as verify the lighting system. Once everything is in order, prepare the machine in its transport position. In this segment, we're preparing the machine for operation by moving it from its transport position to the working position. The end disc, previously folded up, is secured by a pin. First, remove that pin, then lower the disc into its working position. Finally, secure it with the pivot pin and linch pin. This ensures the disc harrow is ready for effective field work. In this slide, we see a disc harrow in action. The first two images display the disc harrow from the side, showing the equal working depth of the first and second rows of discs. This is essential for ensuring uniform soil preparation. To verify the even depth, you can either measure or check that the harrow's longitudinal axis is horizontal. On the third image, we can observe the interaction between the two rows of discs. This is important for understanding how the discs work together to achieve consistent soil disturbance and effective soil preparation. The alignment and overlap between the rows ensure that the soil is evenly processed, preventing any missed or overworked areas. The next two images show the disc harrow from the rear, highlighting how it stands horizontally along the transverse axis. This confirms that the harrow is properly leveled, ensuring that the discs operate uniformly across the entire working width. In this video, we see the disc harrow in action on the field, efficiently processing the soil along with the harvest residues, straw, and weeds. The harrow operates at an optimal working speed, effectively incorporating the leftover crop material and weeds into the soil. The evenness of the soil processing indicates that the harrow is functioning correctly, ensuring uniform depth and proper management of the harvest residues across the entire working width. However, if the soil shows signs of uneven disturbance or if the crop residues and weeds are not sufficiently incorporated, it may signal improper adjustment or an incorrect working speed. Proper calibration and maintenance are essential for achieving the best results in soil preparation and residue management.